All right, concept 4 is all about solving radical equations. This stuff is pretty easy. You just have to remember to do one thing, and I'll talk about it in a minute. But first, our objective is I can solve radical equations using different methods. I'm going to abbreviate different methods. Okay, so I can solve radical equations using different methods. That is our objective for today. So steps to solve radical equations right here at the top. So number 1, isolate the radical on one side of the equation. Isolate means get by itself, get the radical by itself. All right? So number 2, raise each side of the equation to the power of the index. Whatever the index is, that's the power you're going to raise each side of the equation to eliminate the radical sign. That's the whole point. The whole point is to get rid of the radical and solve for x. Okay? So solve the remaining equation. Whatever's left over, you're going to solve it using different methods. There's going to be lots of different things you're going to have to do. Okay? And then number 4, and this is the most important, check for extraneous solutions. And I'll explain that in a minute, what that looks like, okay, if we come across a problem like that. So let's get started. Let's start solving these. We're going to do all the odds together in the video, and then in the class we're going to do all the evens. All right, so here we go. Solve each equation. Be sure to check for extraneous solutions. So our first step, number 1, isolate the radical. So find the radical first of all. Here it is. Is it by itself? No. 5 is being added to it, so I need to get rid of that 5 by subtracting it to the other side. 12 minus 5 is 7. Now, the radical is isolated. It's by itself. So now we can move on to step 2. Raise each side of the equation to the power of the index. If there is no index, it's automatically 2. So we're going to raise both sides of the equation to the second power. Both sides. Not just one side, both sides. Okay? The whole reason we did that was to get rid of the radical sign. So all that's left on this side is x. 7 squared is 49. So x equals 49. But now we have to check to make sure. So all you're going to do to check is plug it back in to the original. Plug back in. Okay? So let's do that. To the original, the very, very first one. Let's check to make sure we actually get 12. So the square root of 49 is 7. 7 plus 5 equals 12. Does 7 plus 5 equal 12? Yes, it does. So it works. Okay. All right, let's do number 3. Okay. Isolate the radical. This is my radical right here. I want to get it by itself. 10 is being added to it. I need to get rid of that 10. So minus 10. That is now gone. Square root of a plus 7 equals 1. Right, step number 2. Raise each side of the equation to the power of the index. If there's no index, it's 2. So we're going to raise it both to the second power. To get rid of the radical, so all that's left on the left side is 8 plus 7. 1 squared is just 1. And now we can solve. To get a by itself, all I have to do is minus 7. Negative 6. But we have to check. I forgot to write check on the last one. So check. Plug it back into the very first one. So a is now negative 6. Okay. Let's check and make sure that if we plug in negative 6, we get the same thing that we started with. Let's check, does this whole thing equal 11? So let's figure that out. 10 plus Negative 6 plus 7 is the square root of 1 equals 11. What's the square root of 1? 1. 10 plus 1 equals 11. Yes, it works. Okay. All right. Number 5 looks a little different because it's not in radical form, but it's in exponential form. We know all about that, so let's figure out how to solve it. Isolate the radical. This little thing right here tells me what's in the radical. Anything in parentheses is what's inside the radical, so we need to get this thing in parentheses by itself, which means I have to get rid of this negative 9. And this is saying negative 9 times c minus 12 to the 1/2. So to get rid of anything that's being multiplied, I have to divide. So now that's gone over here. So all we have left on this side is c minus 12 to the 1/2. And negative 36 divided by negative 9 is a positive 4. Okay, let's think back to rational exponents. Our index is what part of the rational exponent? If you said or thought denominator, you are correct. This is our index. So according to step number 2, way up here, raise each side of the equation to the power of the index. The index is 2, so I raise it to the second power on both sides. Okay, so now what that did is that got rid of my rational exponent, which is the same thing as the radical, so those go away. So all that's left on the right side is c minus 12. Okay, but now we need to figure out what's on the left. 4 squared is 16. And now we just solve for c. Add 12. So c equals 28. But we still have to check to make sure it works. Every single time, yes. I know you're thinking, do we have to check every single time? Yes, you have to check every single time. All right, so let's check. Plug it back into the very first one. C is now 28. Okay, so I plugged it back into the original. Using PEMDAS, so we're going to do what's inside the parentheses first. 28 minus 12 is 16. Now we're going to do exponents. 16 to the 1/2 power, which is the same thing as the square root of 16, is 4. All right. Negative 9 times 4 is negative 36, which equals negative 36. So it works. Works just fine. Okay. Let's try number 7. I need to isolate the radical. This is my radical. So I need to add 9 to get rid of that minus 9. So this is the 4th root of 8k plus 12 equals negative 11 plus 9 is negative 2. Step number 2, raise each side of the equation to the power of the index. So my index is 4, so I'm going to raise everything to the 4th power. Okay, so that took away this. So now all that's left on the left is 8k plus 12 equals negative 2 to the 4th. Well, that's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 again is 16. And since it was negative and this is positive, it's a positive 16. Okay. And so now we solve. This is a simple 2-step equation. We have to subtract 12. 16 minus 12 is 4. Divide by 8. K equals 4 divided by 8 is 1/2. So that's my answer, but I have to check. Will it work? Let's check and see. 4th root of 8 times 1/2 plus 12 minus 9 equals negative 11. So, parentheses first, 8 times 1/2 is 4. So 4 plus 12 minus 9 equals -11. 4 plus 12 is 16. 4th root of 16, we know that that's 2. 2 minus 9 is -7, which does not equal -11. So this does not have a solution. 1/2 does not work, and there's nothing else. So this has no solution. That is why we check every single time. You might get an answer, but it might not work in terms of the equation. So this one, because we checked, we know that this has no solution because the only solution we came up with doesn't work. All right, so I'm going to stop this video and we're going to continue on in the next one.